We're going to switch over to series now. So we had a look at sequences earlier on. Now we're going to look at series. A series is formed when the terms of a sequence are added together. Okay, so we're adding everything up. So we're not just listing them out, we're adding them up. So here's an example: 2, 5, 8, 11, 14, and so on. That's an infinite sequence. But what we have here, if we add up all the numbers, we would call that an infinite series: 2 plus 5 plus 8 plus 11 plus 14 and so on. Now, an important part here is sigma notation. That's the Greek letter sigma. And in mathematics that means the sum of. That's what it's taken to represent. And it's generally used to express a series in a very concise way. So for example, if we have 2 plus 4 plus 8 plus 16 plus 32, can we come up with a way of expressing that? Well, how we would go about doing that is we would say 2 plus 2 squared plus 2 cubed. So we're dealing with numbers from 1 to 5. Okay, so essentially how we might express that is like this. The sum of 2 to the power of r from r is equal to 1 to r is equal to 5. Okay, and that's how that a summation like that would be written. So 2 to the power of r would be the rth term, where r is some integer. It would be the rth term, so like 4th, 5th, 6th, or something like that, in the sequence. But since we're summing up all the terms from 1 to 5 inclusive, the least value of r is placed below the sigma sign. I'll just give you a cue here. That's what I mean there by that. And the greatest value of r is placed above it. So we have, down here we have the greatest value of r. A finite series, it always ends with the last term, even if the middle terms are omitted. Okay. Now, that's the one we sort of write it. So that's just to sort of give a cue. That's what I mean when it always ends with the last term. So if you're writing it out like this, you have 1 over 4 plus 1 over 6 plus 1 over 8. Then you have these dots here, ellipsis, but you will end it with 1 over 42. Now, here's an example here. Oh, sorry, that's an example there of what I mean by that. So that just gives a sort of a picture of how to properly represent a finite series. Now, an infinite series may also be written in sigma notation, but at the top you will see that the upper limit is infinity. Essentially what you're saying is that there is no upper limit. So just notice here, there's no ending term, there's no last term, so we put the infinity here up at the top. So that's an important step there as well. So the last part is write the following series using sigma notation. So here we have all the square terms, and the last term there is 81. Now, so it's 1 plus 1 squared plus 2 squared plus 3 squared plus 4 squared all the way up to 81. So writing it like that, we'd simply write this as the sum. I'll write it r equals 9 from r equal to 1, and that is simply r squared. Okay, so r is 1 squared, then r equals 2, add that, and so on, until we get up to r is equal to 9. Now, 1 minus x plus x squared minus x cubed plus x to the power 4, and so on. Now, just as a remark, this is actually a really nice little trick. In a series where the sign alternates from positive to negative, like we have it there, minus 1 to the power of r may be used for signs. Minus 1 to the power of r results in the terms being positive, even terms being positive, and odd terms being negative. So, minus 1 to the power of r plus 1 will give you the opposite, results in even terms being negative and odd terms being positive. What we have here, so anyway, let's look at this now. What we have here are powers of 0, but this lowest power here is x to the power of 0. Okay, just to add to that, anything to the power of 0 is 1, so minus 1 to the power of 0 is 1. Okay, so what we have here is the sum. Oh, by the way, it's an infinite series, so we're going to have an infinity up at the top. And the starting value is 0. So rather than r equal to 1, in this case we're going to have r equal to 0. Now, minus it, we're dealing with this first example here, or this first scenario here. Even terms are positive. See, plus x squared. So minus 1 to the power of r. And then we have simply x to the power of r times x to the power of r. And that really covers everything there. Okay. So we'll end that presentation there. That's this introduction to series and sigma notation.